Hey everyone, and a giant thank you to Iceni for sending this our way, this Newsweek article. It's pretty shocking, actually. Before we get into it, though, I want to take a quick second to thank all of you, our listeners. You guys are really the reason we do this, and if you're enjoying these deep dives, uh, well, hit that subscribe button, like the video, and of course, share it with your friends. It really does help us grow and keep bringing you fascinating stuff like this. So this Newsweek article, it dives into this study. And they found something really unexpected about wastewater treatment plants. You know, the ones that are supposed to clean our water? Well, they aren't removing those forever chemicals, the PFAS, nearly as well as we thought. It could mean that millions of us are drinking water with way higher levels of PFAS than anyone realized.
And you know, what's really crazy is that we've been using these PFAS, these forever chemicals, for decades. Like since the 1940s, they're literally in everything. Non-stick cookware, stain-resistant fabrics. I mean, you probably have something with PFAS in it right now. But the problem is these chemicals, they just don't break down, not in the environment and not in our bodies, hence the name forever chemical.
So they're everywhere.
Mm-hmm.
They stick around forever, and now we have this study which was published in the Proceedings of the National Academy of Sciences, and it says that less than 25% of PFAS is actually removed during wastewater treatment. That's a pretty terrible success rate.
Yeah, and it gets worse. When you really think about what that means, it means that something like 23 million people in the U.S. could be drinking water with these higher levels of PFAS. And that's not even considering the impact of droughts, which many of us are dealing with now. Water scarcity and higher PFAS concentrations. I mean, that's a recipe for disaster.
Right, and I know the EPA, they regulate certain types of PFAS, 6 to be exact, but this is where the study gets really interesting. They found that these 6, they only make up about 8%. 8% of the total organic fluorine found in the wastewater.
So it's like we're only seeing the tip of the iceberg. There's all this massive PFAS that's totally unregulated, and we don't know what's in there. We don't know what the long-term effects might be.
And it gets even crazier. The study uncovered this major source of these mystery PFAS. And get this, it's prescription drugs.
Yeah, they found that a huge chunk, maybe 62% to 75% of this extractable organic fluorine, it's coming from medications that people take every day. And these pharmaceuticals, they're designed to be potent, even in really tiny doses. So it really makes you wonder about the long-term effects, even at these low levels through our drinking water.
So it's not just industrial waste anymore. It's our medications that's contributing to this problem, too. Really changes how we have to think about PFAS, doesn't it?
Absolutely. It raises some serious questions about how we regulate PFAS. I mean, is focusing on these 6 specific types enough? Are we missing a huge piece of the puzzle by ignoring all these pharmaceuticals and all these other unregulated PFAS?
I mean, it feels like we're always trying to catch up. Like we're always discovering new sources of these forever chemicals.
Yeah, but the good thing is we are getting this information now. And I gotta say, these findings, like the link to medications, I mean, that's groundbreaking stuff.
Good, but how do we fix this? I mean, we know they're everywhere, and we know that the wastewater treatment isn't really working. What can we actually do?
Well, we have to understand we're dealing with something that's always changing. This study, I mean, it really shows us how much we don't know about PFAS. More research, I think that's crucial, not only to find all the sources, but to really get a handle on what they're doing to our bodies, especially long term.
Yeah, it's not just about how much is out there, but what they're actually doing, right?
Yeah. Right. And while we're doing that research, we really have to rethink how we're treating wastewater. I mean, the traditional methods, they're just not cutting it. We got to invest in new technologies, new processes that can actually remove these chemicals.
And should we be, I don't know, looking upstream? Like, do we really need PFAS in all these products? Are there other, I don't know, safer options?
Absolutely. If we can reduce how much is getting out there in the first place, that'll help a lot with the treatment side of things.
It's kind of crazy. I mean, this article made me think about all the stuff I use every day, and I never even considered what was in it. It's like this whole hidden world of chemicals.
And that's the thing, right? We often don't know what we don't know. I mean, look at the study. We thought we knew about PFAS, but then boom, we've got this whole new thing with pharmaceuticals.
Yeah, and it's not just that they're adding to the PFAS problem, but I mean, these are medications. They're designed to do something. Doesn't that make it even worse?
Oh, absolutely. These are substances, I mean, they're literally designed to be powerful, even in small amounts. So the question is, what happens if we're exposed to them all the time, even at low levels in our water? I mean, that's something we need to figure out fast.
It's almost like a double whammy, right?
Yeah.
Not only are they part of the problem, but they're also like medications.
And don't forget, it's not just one or two drugs here. It's a lot of them, a lot of common medications that are ending up in the wastewater. So it's pretty widespread.
And then on top of all that, the study mentioned droughts. Something about droughts making it even worse.
It all comes down to concentration. When there's less water, like during a drought, the contaminants get packed in tighter, higher concentrations. So that means more PFAS, potentially above safe levels, and more people at risk.
So it's like all these things, the PFAS, the droughts, it's like the perfect storm,
It
right?
can seem that way, yeah, but I think instead of freaking out, we need to focus on what we can do. This study, I mean, it's a call to action, right?
So what can we do? What can our listeners do? I mean, it's easy to feel overwhelmed by all of this.
Stay informed. That's the first thing. Talk to your local water utility. Find out about the PFAS levels in your area, the EPA website. That's a good resource, too.
Okay, so we're informed, but what then? I mean, can we actually do anything to change things?
Absolutely. Never underestimate your voice. You can talk to your elected officials, make sure they know this is important, push for stronger regulations, more research funding. I mean, a totally new way of looking at PFAS. I mean, public pressure, it can really make a difference.
This whole thing has really got me thinking, our choices as consumers, the stuff we buy, the medications we take, I mean, it all has consequences that go way beyond us.
Right, we're all connected, like
Yeah.
an ecosystem. And what we do, it has ripple effects. Some we mean to do and some, well, we don't. And in this case, those effects are impacting our health, our communities, even the environment.
So it's not just about me making good choices, it's about the whole system, right?
Yeah, we need both, right? Individuals making informed choices and the policymakers doing their part. We need regulations, research, and solutions. It's got to be everyone.
This has been, well, way more than a deep dive. It's like a wake-up call. So huge thanks to Iceni again for sending this Newsweek article. It's really changed how I see things. And to everyone listening, remember, knowledge is power. Stay curious, stay engaged, and let's keep diving deep into the stuff that matters.